Hello and welcome back to Geometry. Today we will cover section 2.4, Deductive Reasoning, and complete the guided notes. Now before we've used inductive reasoning to analyze patterns and make conjectures, today we will use the law of detachment and the law of syllogism, which is something that detectives might use when trying to solve various cases. Very useful. First up, going over what we'll learn, let's scan through the text and write down two facts that we learned about deductive reasoning. As I have looked through here, I noticed something down here about something being valid or logically correct. A reminder about our inductive reasoning and the use of counterexamples. So we could use a counterexample to prove something was false, but not to prove something is true. But here it says to prove a conjecture requires deductive reasoning. So the first thing about deductive reasoning I wrote down is that it can be used to prove a conjecture. Before we could only disprove it, now we have tools to prove it. And then I looked a little bit further. We had this first law of detachment, some examples to follow. And then the second section is called law of syllogism. So there's two things here called laws. Sounds like we better follow them. So that was my second fact about deductive reasoning, is the existence of those two laws, law of detachment and law of syllogism. So with that planned out, let's go ahead and read the body of the text, and we'll note the vocabulary terms as we come to them. Section 1, Law of Detachment. The process that detectives use to identify who is most likely responsible for a crime is called deductive reasoning. Unlike inductive reasoning, which uses a pattern of examples or observations to make a conjecture, deductive reasoning uses facts, rules, definitions, or properties to reach logical conclusions from given statements. That's quite a bit here, but I want you to really notice the difference here between patterns versus facts, rules, and definitions. Inductive reasoning, let's see if I have some space here on the side of our notes to write this down. Inductive reasoning goes from a specific pattern and from that you make a conjecture about a general rule. Deductive reasoning is the opposite. Deductive reasoning, we will take general rules and we will make a conclusion about a specific instance. Okay, with that said, we should be able to identify the definition right here in the middle. Deductive reasoning uses facts, rules, definitions, or properties to reach logical conclusions from given statements. As usual, we'll go through the examples in part 2 of the video. While one counterexample is enough to disprove a conjecture reached using inductive reasoning, it is not a logically correct or valid method of proving a conjecture. So valid here just means logically correct. You have successfully followed all the rules of logic, then it is valid. To prove a conjecture requires deductive reasoning. One valid form of deductive reasoning is the law of detachment. And here it is. Law of detachment, this is read as if P then Q, but I don't want to say if twice. So let's say if P implies Q is a true statement, and Q is a true statement, and P is a true statement, then Q is true by itself. This is the detachment part. Take a look at the example. Given, if a car is out of gas, then it will not start. That's a general fact that applies to any car, anywhere. That is how cars work. Sarah's car is out of gas. So this is a specific instance of the hypothesis being true. So our valid conclusion, we have detached the conclusion of the conditional into a separate logical conclusion. Sarah's car will not start because Sarah's car is out of gas. And as we all know, any car that's out of gas will not start. So we combine those two together to make this separate valid conclusion, where before we could not simply state categorically all cars will not start. That would not be true, but this specific one is. Yes, some of these will be painfully obvious. That's okay. As long as the facts given are true, the conclusion reached using deductive reasoning will also be true. Okay, and that leads us to our definition for law of detachment. A form of deductive reasoning that states that if all the facts are true, then the conclusion reached is also true, referring to the conclusion of the conditional statement there. So to help you remember that name, think of your detaching the two parts of the conditional that were normally stuck together. Let's keep going. You can also use a Venn diagram to test the validity of a conclusion. So again, useful visual aid there. We'll go through this example in detail, but notice how they're creating their categories and putting some points within those categories. This one's in here, so it's not in there, or it is in here, so it's also in the other one, that kind of thing. All right, second law, law of syllogism. The law of syllogism is another valid form of deductive reasoning. This law allows you to draw conclusions from two true conditional statements when the conclusion of one statement is the hypothesis of the other. Conclusion of one is the hypothesis of the other. We want to see that. Oh, let me write, come on. We want to see the overlap. So symbolically here, if P implies Q and Q implies R are both true statements, then P implies R is a true statement. Take a look at the example. If you get a job, then you will earn money. Absolutely, that's how jobs work. And if you earn money, then you will buy a car. Okay, let's say you can buy a car. That one we could say is definitely true. Maybe you have no plans to buy a car, but we'll go with it for now. Let's assume that one's also true. You will buy a car. So the valid conclusion we can come to is skip the middleman. If you get a job, then you will buy a car. This is we're creating shortcuts here. Think of it that way. So the law of syllogism here allows you to draw conclusions from two true conditional statements when the conclusion of one statement is the hypothesis of the other. Notice, though, that the conclusion itself is an entire conditional statement. It is also important to remember that if the conclusion of the first statement is not the hypothesis of the second, no valid conclusion can be drawn. You have to have that overlap. You have to be able to cut out the middleman, create the shortcut. So we'll compare some examples and non-examples in part 2, and that is the entirety of the text. And also, finishes the active vocabulary. Let's see the vocabulary link. Syllogism is a word used in everyday English as well as in mathematics. Everyday is a bit of a stretch there. Look up syllogism in the dictionary. Explain how the English definition can help you remember how syllogism is used in mathematics. This one was a bit tough because honestly, the English definition is highly mathematical. It is all about logic. If you look up syllogism anywhere, I've tried multiple dictionaries, they just kind of either give a very specific example of the law of syllogism itself or a very broad statement of, well, a syllogism is using logic. It's using deductive reasoning. But more specifically, a deductive scheme of a formal argument. So remember, it is formal. We're being very specific here. Consisting of a major and a minor premise and a conclusion. So what they're referring to as the major and the minor is we're going by category here. We start with one, and then the other sort of nests inside there. And you would see that when we do examples with the Venn diagrams, how one premise could fit inside of the other. And you get the conclusion. How that differs enough to help you remember it separately from the math definition, I'm not entirely sure, but there it is. So let's go on to the main idea organizers here. First up, we have law of detachment. Let's identify the steps to validate two conclusions by completing the graphic organizer. And here I will actually go back to one of the examples because they list out those steps. Using the law of detachment, step 1, identify the hypothesis P and the conclusion Q of the true conditional. So here is my setup. I have, let's number these 3 statements. Statement 1, statement 2, and statement 3. Only statement 1 is a conditional that says if the light bulb is broken, the lamp will not work. There is a hidden implied then here. So the hypothesis of that statement, I believe we have been, did we circle or underline? I want to be consistent here. Circle, hypothesis, underline, conclusion. Yep, let's do that here. Too far. The light bulb is broken. Then the lamp will not work is the conclusion. The light bulb is broken, then the lamp will not work. Okay, step 2 says to analyze the conclusion. And here we're talking about not just the conclusion of the conditional, we mean the conclusion of the argument. First, look at the other statements. What do we know here? We are told Jackson's lamp will not work. Okay. And then statement 3, Jackson's light bulb is broken. Does this statement follow from the other 2? That's what we're asking for. When we say analyze the conclusion, is it guaranteed from the other 2 statements? Does this match one of our forms of valid reasoning, specifically law of detachment? So the law of detachment requires us to have it set up a conditional, verify the hypothesis so that we can conclude the conclusion as a separate statement. So the thing we have to look for is a repeat of the hypothesis. Did we state that the light bulb is broken. This is what we were given. Jackson's lamp will not work. What we have done here is we have actually repeated the conclusion. So, no. No, we repeated the conclusion. Therefore, the conclusion, that is to say statement 3, is not valid. Now, if they had gone the other direction, if they had simply switched the order here, say, oh, if the light bulb is broken, I know the lamp won't work. Jackson's light bulb is broken, therefore Jackson's lamp will not work, then yes, we have the general conditional setup. We repeat the hypothesis with a specific instance, then we get the specific conclusion detached as its own independent conclusion. But that's not the order that was presented. That's not the argument that they gave. They want to imply that I know the light bulb is broken because the lamp doesn't work. That's not guaranteed. Maybe the lamp doesn't work because the cord is broken. Okay? You don't know that it's the light bulb at fault here based on only these two pieces of information. Next up, law of syllogism. Match the portions of each statement with the correct term by drawing a line to connect the two. Then write the true conditional statement and the valid conclusion using the law of syllogism. Okay, we want 3 statements here, and here are 3 potential statements. Let's remind ourselves on law of syllogism here. That should be in the form of, we need if P then Q, and if Q then R. Therefore, if P then R. So we have P, Q, and R in that order. Technically, we are free to, we don't have to use those letters in that order. But then, to make it interesting, let's try to stick to that we actually get some crisscrossing lines here. So what's the first thing we could use here? What is the first inciting incident that could lead to another one? I think the first thing would have to be you walk to the store. And that implies, P implies Q, you walk to the store. That implies that you buy bread. So if you walk to the store, then you buy bread. And Q implies R, if you buy bread, then you can make toast. So we can put those together to get our final conclusion. If P then R, we want to write the true conditional statement and the valid conclusion using the law of syllogism. Now this is a little misleading when they say and the valid conclusion. The one conditional statement that is the valid conclusion, the law of syllogism. They're not two separate things here. If you walk to the store, then you can make toast. Now, part of the magic of the law of syllogism is that we know the conclusion is true because we know the middle steps that we've eliminated. Somebody else might not know that. If you just tell somebody, hey, if you walk to the store, then you can make toast, they might look at you a little funny. Well, how do you know that? Ah, well, if you walk to the store, you could buy bread. And once you buy bread, then you can make toast. You fill in the missing links for them and now they can follow along. All right. Finally, helping you to remember, a good way to remember something is to explain it to someone else. Suppose a classmate is having trouble remembering law of detachment. In your own words, explain what the law of detachment means. Ooh, okay. This does say in your own words, so I'm going to leave this one here for you to fill in on your own. If I write it, you'll copy me, and it won't be your own words. So I want everybody to come up with their own explanation here for what law of detachment means without simply copying the definition from above. And then come back to part 2 for the example problems. So long, farewell, enjoy the rest of your day.